Good day to you all again. Evan Snyman for Umhloko, Making a Difference. Our third and last section in the chapter on functions and inverses. Today we're going to be looking at some exam questions. Okay, so let's have a look. Okay, so here we've got a quarter x squared. Okay, x is less than naught. We have discussed this already. We've seen that because this is just quickly having a discussion about it, because this is going to be a parabola, we can't, this would be a many to one. And so as a result, what we need to do is we need to remove the one side of it. And we do that by saying x is less than naught. So actually in this case, they've decided to do the exact opposite. And that's important to realize that there's no reason we couldn't do that. That in this case, they've decided to remove the right-hand arm by saying the only x's they want are the ones that are less than naught. Okay, so again, nice and simple thing to work with. A nice stock standard question, find the equation of f minus 1. Well, we've seen that there is a method for it. Y equals a quarter x squared. X is less than naught. Swap x and y around. X is a quarter y squared. Y is less than naught. Therefore, 4x equals y squared. Y is less than naught. Therefore, the square root of 4x equals y. Y is less than naught. Now, we would need to put in the negative square root of x in this case because we want y to be less than or equal to naught. Okay, on the same system of axes, sketch these two things. Again, no big shake here. We should really be seeing this question as being fairly straightforward marks. Okay, so we've had discussion up top here quickly. We know that we've got the parabola with x is less than naught. So we know that the original function will do this. And here's f of x. Okay, it goes through naught. And let's put a value in here. Let's put in, for example, 2. So actually, yeah, let's put in 2. So, or minus 2. Minus 2 squared is 4. A quarter of 4 is 1. And so it goes to the point minus 2 and 1. Okay. And we want to now sketch the graph of f to minus 1. Well, again, we know it's going to start at the origin. And we know that whereas this was the point minus 2, 1, it's now going to the point 1 and minus 2. So we know it's going to go through this point here, 1 and minus 2, and it's going to sit, it's being a parabola over there. And this is the graph of the inverse function of x. Okay. Do we have any other x and y intercepts? Because I do specify we must clearly indicate the intercepts with the axes. No. As well as another point on the graph of each of these. Well, we've got that. We've got the green point minus 2 and 1. And we've got the red point 1 and minus 2. So everything that we need us to do in that instruction set, we have fulfilled. We're fine. Is f to the minus 1 a function? Give a reason for your answer. Now, it's a little bit tricky because it's not the first part, it's the giving the reason that's the issue. So 6.3, the answer is yes. Okay, it is a function. Now, you can say a range of things here, okay? So I would suggest that what we're saying is with restriction, with the x is less than or equal to naught restriction, f of x is a 1 to 1 function. Or I would say as an alternative, I'd say a vertical line test only cuts f to the minus 1 of x once at most. Okay, because remember the definition of a function was that that a vertical line may only cross the graph a maximum of once. Okay, the answer of it doesn't cross is actually an answer. Okay, so again, these 8 marks, I would suggest if we are trying to build towards a symbol, or if we do have a goal in mind in terms of our maths mark, I would suggest that we get used to these questions. You'll see that the other two that I've got in the next two slides are not that dissimilar and are going to help us get to this goal. Okay, so these are, I would suggest, are fairly easy marks. Okay, I know that what's easy for some is not easy for others, but there is a routine to finding f to the minus 1. There's a routine to drawing the graphs, and the only real tricky part is how to give the reason for 6.3. Okay, let's have a look at the second part, second slide. Okay, now in this case, they've told us that ax squared is drawn. So we know it's a parabola, okay, but we do not know what the value of a is. Okay, it is drawn in the interval of x is less than 0. We can see it's drawn on the left-hand side. Again, I would probably want to be using a highlight or something just to make sure I know what they're talking about here. F of x is that one, and it is this function here. Okay, it's this one coming down here. Okay, f to the minus 1 is the other one, which is sitting over here. Now, because we've got a negative parabola, I'm hoping that what is screaming at you is already is that therefore a should be less than 0. Okay, the graph of f to minus 1 of x is drawn. Okay, the point minus 6 minus 12 is a point on f. Okay, so very clearly they're saying that here is a point on f. Okay, and r is a point on f to minus 1. Okay, is f to minus 1 a function? This is the same as the question we've just looked at, and the answer is yes. Okay, the original function f of x is 1 to 1, or a vertical line test on f to minus 1 only cuts once. Okay. If r is a fraction of p in the line y equals x, write down the coordinates of r. Well, again, we've seen this a couple of times now. If we talk about y equals x, then minus 6 minus 12 is simply going to become minus 12 minus 6. What used to be the y value is now the x value, and what used to be the x value is now the y value. So not only is y equal to x, but x is also equal to y. Okay, now again, you can see from the mark calculation that they think these things are fairly straightforward. Okay, 4.3, calculate the value of a. Well, all we're going to do is substitute in. So minus 12 equals a times minus 6 squared. So we're getting, what are we getting from this? Minus 12 equals a times 36. So minus a third equals a. Not a problem. Write down the equation of f to the minus 1. So again, last time they did it in the opposite order. They asked us to find f to the minus 1, then draw the graph, and then comment on it being a function. Here they asked us to comment on it being a function, draw the graph, and now find the algebraic equation. So again, we know how to do this. Okay, I'm going to choose to just move the graph up a little bit here. Okay, and put it in here. So we know that we've got a routine for it. So y equals minus a third x squared. X is less than 0. So x equals minus a third y squared. Y is less than 0. Please don't forget to do the change the letter on the restriction as well. Okay, so minus 3x equals y squared. Okay, y is less than 0. Therefore, the negative square root of negative 3x equals y. Y is less than 0. As a result, we have that negative square root negative 3x equals f to the minus 1 of x. Oh, okay, and we didn't need to go that far. Again, important to make sure we answer the question. They said write it, so let's quickly go there. Write in the form y equals. So in other words, this last line here was almost a waste of time. It's not wrong, it's just a waste of time. We did not need to waste time on that extra line. Okay? So again, try and make sure you read the questions and that you answer the questions. Okay, so we're going through this quite quickly, and unfortunately, we're going to look at the next question, which is a slightly different question. Okay, and again, this one contains no pictures, just a bunch of information. Okay, so again, let's have a look. We've got an instruction to, on the same set of axes, draw the graphs of these things. Okay, so we know that minus x plus 3, so let's just take this one as, so let's quickly just color code it for us to make our lives a little bit easier. Okay, so we're going to make this one red. So minus x plus 3, we know is going to do something along the lines of that. Okay, and we know that's going to have a y cut at 3. And if you think about it, it's going to have an x cut at 3. Okay, if we look at the second function, g of x, and I'll label the functions shortly, okay, then we know that, okay, so this was f. If we are looking now at g of x equaling log 2 of x, we know that this is going to have this typical shape. Sorry, wrong color. It's going to have this typical shape. Okay, and it's going to have a x cut at 1 because there's no transformation, there's no shift on this function. Okay, so clearly showing all intercepts with the axes. Well, the blue function, the log function, is asymptotic to the y-axis, so it never cuts the y-axis, so there's no y cut to it. It's got an x cut, which we have labeled. Okay, now, again, I differ with my colleagues on this, but many of my colleagues, and again, please take heed of what your teacher says to you, will say to you that you can't actually label your axes as in the way that I have done here. And they would say that you would need to label it as being 0 and 3, and 3 and 0, and that my x cut of the logarithm would be 1 and 0, not just simply 1. And I would want you to write it down as coordinates, not as single values. Okay, write down the equation of g of x, of g to minus 1 of x, or g inverse g of x, the inverse of g in the form y equals. Again, no surprises. So we can go for y equals log 2 of x. Therefore, we swap the x and the y around. So x equals log 2 of y. 2 to the x equals y. Our instructions said write in the form y equals. We've done so. We sorted for 6.2. Okay. Explain how you would use the equation 6.1 or 6.2 to solve the log equation 3 minus x equals x. Okay, so let's think this thing through. Okay, so we now have a very unfamiliar situation. Okay, and I'm not going to lie to you. Okay, sitting here right now, this does not look immediately obvious to me. Okay, until you think, well, hold on, the 3 minus x is simply x minus x plus 3 at the top there. Okay, so I can see how this links to the red graph as being minus x plus 3 from earlier. Okay, the log base 2. Well, we had log base 2 in the blue function earlier on. Okay, in the g of x function, the g function. I think I see it now. Okay, so what I'm going to do is I'm going to say, cool, log 2 of 3 minus x equals x. As you said before, if you don't like working in logs, go to their inverse function, which would be, say, therefore 3 minus x equals 2 to the x. Okay, now here is my graph of 2 to the x. Okay, it is the inverse, so this is g to the minus 1. Okay, we've got g over here already. Okay, and we can see that this is actually the same as saying minus x plus 3 equals 2tx. In other words, what they're asking is, where does f of x equal g to the minus 1 of x? Okay, so explain how I'd use it. Okay, having rewritten it here, I now am looking for where the functions of f and g to the minus 1 intersect. Okay, graphs are equal, or equations are equal where their graphs intersect. So I'm looking for the intersection point between those two graphs. Okay, and I could do it that way. And I'd ask you to write down the solution to this. Well, again, let's think through. How would we go about this? Again, I would probably use trial and error possibly here. So let's have a look. Okay, since this is only worth 1 mark, it can't be too difficult. And since we know the answer lies in between 0 and or just to the right of the axis, I'm going to say what I'm going to try to do is say, cool, let's just try it by trial and error. So log 2 of 3 minus x. If I make x equal to 1, I'm going to get log 2 of 2, and we know that this is a log identity, and that log 2 of itself is going to be 1. And we've got here our solution, because if x equals 1, and we're getting an answer of 1, that must equal x, which is what they've asked us to solve. So 6.4 sorted. Again, in this case, I wouldn't try to do any funky maths. I wouldn't try to do any fancy maths. This is a lovely problem-solving question. Even though it's only worth 1 mark, I'll suggest it's a problem-solving question because there's no other way to solve this one other than simply reverting back to trial and error, whereas we might be thinking that we need to do some complicated maths. And so in this case, excuse me, the trick is to just have some faith in simple maths, not doing anything too fancy. Okay. What I hope you notice is that for this topic, which is a fairly short topic, the theory was quite dense, but the exam questions are all actually of the same type. Okay, and so the real changes between these 3 questions here was here previous one. Here I gave you were given the coefficient of x squared. Okay, coincidentally they asked about parabolas in both of these two types. Okay. Whereas in this type, they did not give you the coefficient of the x squared. It asked you to do some working on it. But in all 3 cases, they've gone through pretty much the same steps of do something with the sketching of the graph, do something with the reflection in the line y equals x, and definitely going to ask you to find the equation of the inverse function of x, of f or g or something like that. And you've got a set routine, step 1, step 2, step 3. So even if you didn't necessarily enjoy this topic, there are routines that you can follow that will ensure that you get a decent bundle of marks in this topic. Okay, all the best going forward. Thank you.